Might as well just move your laptop back in there, actually.
Oh yeah, huh?
Mm-hmm. All right. So, movement of Earth, or movement of continents across the Earth's surface, the Earth splitting, that's a new one. Movement of continents over a period of time. Ooh, I like the period of time part. The movement of I don't know. Um, well, you better move that I don't know to a different response because I don't accept IDK unless you're like a fourth grader. The moving of continental plates. And yeah, so all of those but the splitting pretty spot on. And the IDK, which will drive me to my deathbed. Thank you, whoever did that. All right. Alfred Wegener, because in Germany they pronounce their W's like V's because they're weirdos, so it's Wegener. So he was a German meteorologist, and if you don't know, meteorologists are the people who do weather and study the atmosphere. So it seems kind of weird that somebody doing that would kind of figure out plate tectonics. He lived from 1880 to 1930, and he's credited with the theory of continental drifts, which he came up with during the 1910s. I think 1912 is when he published his book. He wasn't the first to have the idea, but he was the first scientist to present the evidence. So kind of like Darwin, he wasn't the first to have his ideas either, but he was the first to have some supporting evidence. So same thing goes for this guy. Science, evidence, important. That's how you get your credit. I don't remember how many notes you guys have on these pages. There are, I will warn you, there are a couple slides that Nearpod cuts off, so I'll be sliding my PowerPoint over to help you out. Let me know when you're done. Yep. All right, so one thing you guys have probably already heard about before is Pangea, the single landmass that existed over 200 to 225 million years ago. This is not the only single landmass Earth has had. I believe Pangea is the seventh, but it's the one most commonly referenced because it's the one that's the most recent. So that's why we talk about Pangea a lot. And it's the one where we can recognize the shapes and the outlines of our current continents. Rather than like Pacific and Atlantic Ocean or anything like that, Panthalassa is the single ocean that existed surrounding Pangea. Now, one of your assignments last week asked the question, what would happen? Good morning. What would happen when the core cooled down? And the answer was that would slow the convection currents down, that would slow the movement of the plates. So we wouldn't have any new crust forming. What would happen over time is that all of these land masses would erode and wither away and basically go to the bottom of the ocean. So we would be a world of water, or water world. So that over time, in many, many thousands and millions of years, that's what would happen. All right. Yeah, one of my seniors wrote that. You guys have already kind of seen this map, but I just wanted to point out one bit of thing on there. Most of our plates move in like a single direction, especially our smaller ones like the Nazca plate. A couple of the really crazy plates are the African plate, where you can see you have arrows going north. You have arrows going almost straight east, and so that's where you're going to get future breaking of plates or joining. So you'll see beyond your lifetime, this map would change. Another crazy looking one is Antarctic. You literally have them going almost in every direction. And so that would end up kind of breaking up as well. So you have some south movement, you have some north and west movement, and yeah, so that's another one that would end up breaking. And just kind of some of the things that you'll see as far as continental drift ideas coming from our most recent single landmass Pangea, breaking up into Laurasia and Gondwana, and then starting to actually form, diverge and converge in some cases, the continents that we see today, taking millions of years. So we're going to go over the 4 pieces of evidence of what come up. Sorry, I can't type and talk at the same time. Of why we know continental drift and plate tectonics are a thing. So our first piece of evidence, this is one that cuts off, so let me pull over the, there, I'm going to pull over. I'm going to put that up there because Nearpod cut off a couple of my lines. So the first one is the apparent fit of the continent. So that's the coastlines matching up kind of like puzzle pieces. Before plate tectonics, before Alfred Wegener, all of that, it was believed that the shape of our continents was from waves eroding rock on one continent, moving that sediment to another continent. So that would be like in this picture, for example, that would be why South America and Africa kind of line up. So whatever was basically deleted off of South America got put over on Africa. Huh? Oh, sorry. Let me put that up for you. Hey, Blaze.
I'll try that test in today.
Okay.
I forgot to send it.
All right. VJGXI. It wasn't until the 1960s, and we'll talk about one of these studies in a little bit, but the study of the continental shelves showed that there was even a more concise fit and a more perfect puzzle piece matchup than they had seen through the continents. If you don't know what continental shelves are, that's the area of the continental plate. Like I always think of Florida, how you can still see the bottom.
Peterson?
Yes.
I'm sorry, I didn't know to class started.
Oh, you're fine. What's your name?
No,
What's your name?
Anthony Antoine.
Oh yeah, I just got an email about you last night. Go ahead, have a seat, and we'll play catch up in a little bit, okay? All right. And I'd load up your computer, open your Canvas, all of that. All right. Oh, you don't yet? Okay. Then we'll definitely catch up towards the end of class. Sorry, today will be boring.
See you tomorrow.
All right, see you, Blaze.
You just know.
That means he probably doesn't have an account yet, because he's new.
I'm not.
Yeah, you're not in the system yet. All right. So continental shelves are like, if you think of Florida, and you can see, especially with the clear water, how it looks like the beach kind of extends out really far. Well, it does, and that's called the shelf, because right as that shelf ends, you drop off into deep ocean. You drop off very, very quickly. So that is what they mean by the continental shelves, and I think you'll see that in the video that we'll watch here in a minute. Oops. All right, first part. Three question quiz. One of my classes got 100% yesterday, so you are officially challenged.
Don't know this. Did I get that right?
Maybe. I'll show you guys your names in a second.
Is that third thing?
I don't know. We'll find out. I actually, without unhiding the names.
I think it is.
Or is it the 1 out of 3?
Probably.
I was joking. I don't even think that person started yet.
You computer talk like this? What? Oh, this is fun.
Yes, I know there's a typo in there. Thanks, Isaiah, for pointing that out. I did not type I make the PowerPoint, so you can blame me for the typos in the PowerPoints, but typos in the questions, you gotta blame Mr. Disney.
Oh, it's so weird.
Yeah, drift. There's a slide where I left off the N on Northern, so I have a typo in here too that's driving me nuts. And I can't fix typos in Nearpod, so. Unfortunately, I hate Nearpod, to be honest, but it's the same thing. It's just through Google. Yeah.
That's what I use.
Yeah, because middle school does the Google Classroom stuff. We have to do the Microsoft version. Yep. I like my Plickers cards, but
Do you write on here?
sometimes
You write under here?
you can write wherever you want. I usually have pictures up all on this wall.
Okay. Is there a eraser to the...
You have to wet that. Mm-hmm. For the markers. Yeah.
You can be around for the like night.
So I mean, we're constantly always moving, but it's only at like a maximum of a few inches a year. So it's not like anything, like one of the things I was always told in like middle school and high school is that one day the coast of California is going to shoot up north and be part of Oregon. But that won't happen in our lifetime because that's like 1,000 miles and it's only moving a few inches a year. So we won't get to see much of it. The evidence that we see is heavily like the earthquakes, volcanoes, and things like that are kind of our biggest like heads up. Or you know how Yellowstone has a geyser, like that it's known for. The geyser used to be like on the dot I forget what it was, like every hour or something like that, and now the timing is off. So that's evidence that the hot spot, and we'll talk about that in a second, is moving, and that geyser's not going to be as functional anymore. So that will happen in our lifetime. All right, just waiting on these last few questions to load in. All right, go ahead and look at your answers, which you guys got very, very close. Very close to 100. You were the 3 out of 3, actually. So what was the name of the single landmass? Our most recent one was Pangaea. Then it broke up into Laurasia and Gondwana. If you picked Antarctica, I can't help you. I'll go back in a second, Isaiah. What continent does South America appear to fit? That would be Africa, where like Brazil nudges right up in the corner. It's like they're spooning. And then what does the term continental drift mean? Because Mr. Disney forgot the T. That's when the continents are moving. And we'll talk about the oceans moving in a second in a really weird way. All right. So our second piece of evidence is fossil correlation. So correlation is like finding something similar across a distance. So we find similar fossils. We have this like alligator kind of looking guy. Well, they both kind of look like alligators, but they're both found across South America and Africa. You have this like short stunted hippo looking thing. I don't know. That's going across Africa, India, Madagascar, and Antarctica. I mean, these are all animals that are not alive today, so that's why I'm giving them weird names. And so they're the same fossils found across all these continents that are nowhere near each other. This is both plants and animals. Before any of this was understood about continents moving around, we assumed that animals floated across the ocean or had some sort of like stepping stones, which is really weird to think of a plant using stepping stones to go from South America to Africa, but whatever. That was the previous science at the time. So kind of weird, but and I'm trying to find my next one that cuts off. Oh, did your computer shut down?
That sucks.
It's like one student every class. All right, hopefully I'm okay to move on. Our third piece of evidence is our rock and mountain correlation. So it's the same thing except for its specific rock features and different patterns of rock, just even like you'd see up in Garden of the Gods. It continues out for a very long time. And then things like mountain ranges as well. So you have one range that is shared between South America and Africa, mostly South Africa, and you have this mountain range up here. For us, it's the Appalachian Mountain Range. This whole range right here, when it was connected, was bigger than the Himalayan mountains, so bigger than Everest. The tallest mountain in the Appalachians right now is the same elevation as Colorado Springs, like the bottom of Colorado Springs. It's only about 6,000 feet. So they have been eroded over like 20,000 feet, have gone and created more land as they've separated. But all the way across like Greenland, Scotland, Norway, Africa, we all share the same mountain range. And that's your topographic feature. Mm-hmm.
Okay.
Our last piece of evidence is called paleoclimate data. Paleo, kind of like paleo diet, means like old. And so we're looking at climate data that is really, really, really old. We get that climate information because there was no sensors back then, but we get them in different ways by studying like ice cores and soil samples and things like that. We have a couple cool things that actually are very important to our life in living today. We can find debris of glaciers and scrapings throughout South America, India, Africa, and Australia, meaning there was once enough ice there to create glaciers. And then we find tropical fossils now found in Arctic areas. So one of the biggest ones is the fact that there were tropical swamps in US and Canada. Here's my typo. Northern Europe. Those tropical swamps create coal, oil, and natural gas. So without those tropical swamps being buried and kind of shifted, we wouldn't have the energy to run gas stoves or our cars or trains when they were running on the heat from coal. So, like, without that, we would have lost a lot of energy. And if we didn't know about those paleoclimates, we wouldn't know to go digging for that energy itself.
Tuesday. No. Security guard around here.
That's their job to be seen. All right, quick 4-question quiz. This one is a little trickier. Let's see how you do.
I think I just did it on.
Yes. Despite the fact every student's attempt to try and break everyone in my classroom. No. Yeah, Mr. Disney and I share that. It's back in, like, side the greenhouse, a little past it. You didn't ask.
I'm sorry, I'm careful.
No.
Last year, someone pulled it at school. We had a sub that day too, so I didn't know what to do. So they pulled it.
Yeah, there's a reason it's got. I mean, I have the doors open, but there's a reason it's behind locked doors. And we can lock you in that back room too, so you can't escape. Could ask one of my seniors about that because we did that to him last year.
Ooh, that's pretty good.
Alright, I think. Yeah.
Oh yes, yes, I got a 4.
Yep, sorry. Go ahead. Yep, there's your 4 out of 4, Ashley. Nice job. Yep, sorry. Oh, yours says you're done, but I guess it hasn't popped up yet. There it goes.
No.
We'll see.
It's alright. It takes a while for it to load. So the answer is obviously which of the following, and I do want to correct this one, which of the following is not evidence for continental drift? The correct answer is C, only because, one, we haven't talked about it yet, so that should be your kind of hint. But two, we are going to talk about it later because it's a big part of the rock and mountain correlation and fossil correlation. So when we talk about radioactively dating stuff, we're going to kind of be talking about how it helps with these two. So it's kind of like a sub part of that. Fossil correlation relates to similar fossils on distant continents. So not different fossils, you're going to find different fossils everywhere. And hopefully you find similar ones on the same continent. But this is the weird one. That's the one we look at. And then finally, rock and mountain correlation, kind of the same answer. It's the rocks and similar types on different continents. And lastly, paleoclimate data evidence for continental drift is a shift due to the land masses. So when our land masses move, like it went from Pangaea to Gondwana and I'm spacing out on the other one right now, but the two different land masses, then that changed our ocean currents, and that also changed our atmosphere currents, so our wind patterns and things like that. I'm gonna hit you with that whole bunch. Just kidding. All right. So that is why that is a huge deal for paleoclimate. All right. Opinion question: which evidence? Why are my students not popping up? Which evidence of continental drift is the most important, and why do you think this?
Nice random changes. There you go. Okay.
It kicked you out. Okay. Whoever put the climate one needs to put the Y. This is why you guys are not doing good on some of your assignments. They'll say list and describe, and I get a list.
I just so good that I
I believe that. Mm-hmm.
I'm working on every other class in the year from now.
And why this one last?
Because I like this class, but I don't like doing work at all.
You're welcome.
I used to be really good at science, and then I don't know
As long as it's not the one that's sitting up there right now. Ah, this one? No, I think it's a great answer.
What is the four that we just went over?
Mm-hmm. Out of the four we just went over. ETC. I don't know who put this, but for the record, trees do not block tornadoes. Tornadoes laugh at trees and think of them as little twigs to crack. Talk about. I think we do natural disasters at the end of the semester.
Woo!
It's like my favorite unit, and they put it at the end. So sad.
Better at the end, so I actually do want
As slow as we're going, we might not get to it.
Please hurry up. Wrong.
It's an opinion question. Nobody is wrong. Unless you're not answering, then that is wrong. Good justifications for the most part. All right. So opposition to Wegener. So when Wegener first proposed his theory, other scientists did not accept it. They thought he was dumb and crazy and whatever it may be. There were several reasons why they didn't, or why they justified not believing him. One is that there was no mechanism for the movement of the continents. So he knew everything about them moving, but not how it was happening. And without the how, they were kind of like, well, it's just an idea, so we don't care. He was also a meteorologist dealing with weather and atmosphere, so therefore they believed he had no actual understanding of geophysics or geology in general, even. And then he proposed that the continents moved on the sea floor, not as part of a plate. So it would be like a whole nother layer being the sea floor, and then the continents kind of like chess or checkers pieces moving around on top of that. And they thought that was weird. And then they thought, or he thought that continents were moved by just the tides, the same tides that were like eroding South America and building Africa. And that's how they were also moving around. Oh, this is one that cuts off on your notes, so let me do the whole PowerPoint thing again. All right. We know now that that mechanism that they didn't know or understand previously is the convection currents, the heat from the mantle moving the plates around. And then we have that evidence from seafloor spreading, rift valley formations, and subductions, which I think is your last little thing. Then join it next year.
I can?
Mm-hmm.
Okay. I was literally in CUC science last year, and the year before that, and why am I not in science?
I don't know.
That is racist.
All right, so we're gonna watch a quick video.
No.
I know, and it doesn't work on Nearpod because I hate Nearpod. So I'm gonna pull it up, and for the people online, I'm putting the link in case it freezes. So you have 4 questions in your note packet on this video. It is about Sir Wegener. He's not a sir, I just made that up. This was my entire life yesterday. I got to stare at a loading bar. Mm-hmm. Yeah, I'm experiencing interruptions. I know why. Sometimes it plays better if I don't make it big.
Hardly anyone in the early 20th century century said, why are there oceans and why are there continents? Wegener is a wonderful example of how science benefits from people coming from outside a scientific field and saying, well, why don't you look at it this way? Getting into a balloon and going up into the air for a meteorologist is like getting into a boat and going out on the ocean for an oceanographer.
He goes up in a balloon because he wants to take measurements of the atmosphere. He's not the Wizard of Oz. He's a scientist doing science.
Wegener flew as much and as often as he could. He wants to write the best book on the physics of the atmosphere, and no one had ever studied the atmosphere in the high Arctic before.
This is a time in history when one of the most exciting things you can do as a scientist is to go on an Arctic expedition.
It was adventure travel of a North Pole, South Pole kind. Wegener's out there in the winter night taking these huge box kites and attaching recording instruments to them and then winching them back down to get his instruments back.
Nobody ever said that Arctic exploration was a picnic.
Wegener had to learn how to hunt seals, how to drive a dog sled, how to travel on ice without being swept into open water, how to protect your dogs from polar bears. The travel in Greenland, his time with icebergs,
The way in which the ice floes form jigsaw puzzle pieces.
the way the ice cap splits apart and fissures. All of this was part of his imagination when he made his discovery of continental drift.
I wouldn't really call it a discovery. What he really had was an idea.
He went to his office, and his office mate said, look at this beautiful atlas my parents gave me for Christmas. And he wrote to his fiancée, did you ever notice how South America fits into Africa? Let me pause and say, there isn't a child on Earth over the age of 12 who hasn't had the same thought, right? You can see it. What was different about what Wegener saw? There were lines on the map that represented depths under the water, and they're exactly the same shape. That means that this is part of the structure of the Earth. How did that come about? Maybe the continents drifted apart.
It was radical because it was new. The Americans say the continents are fixed. Europeans think they move, but they think they move up and down. And Wegener says you're all wrong. Yes, they move, but they move horizontally, not vertically.
He would write a paper in 1912, and he said, I think everybody will really be happy. And of course, everyone wasn't really happy. Everyone became very unhappy.
There was a almost universal rejection of his theories to begin with.
Here's the problem. Scientists are very suspicious of fundamental novelty.
He was regarded as an outsider by the geoscience community because he had no academic credentials in that field, and so he was not considered qualified to make any statements in that field. What he was doing that was so different, though, was drawing together multiple lines of evidence, not just geology, but vegetation and paleontology. The botanical people responded very positively because it explained the distribution of plants and animals over the world.
In different places on Earth, you saw virtually the same fossil records. The stratigraphic columns were extremely similar as well. And Wegener's idea, his big idea, was you could explain all of those things if the continents had moved.
So he would write a book in 1915. People said, well, this is wrong and that's wrong. And then he wrote another book in 1920. He comes up with the name Pangaea. And then he wrote another one in 1922. And he kept fixing it and fixing it and fixing it. It's one thing to think of an idea, and it's another thing to work it out for 20 or 30 years.
That book's still available on Amazon.
Continental drift was something he was interested in, but it was never the focus of his scientific life.
The Arctic pulled him back in. He was really too old, almost 50 years old.
He landed there with 98 tons of equipment.
And from the beginning, things didn't go well.
They had many things go wrong.
The base in the middle of the ice cap did not have enough food, and he said, this is my responsibility to resupply.
And he got several sleds together.
It's the worst conditions you can possibly imagine. His companions wanted to give up. And at twilight, Wegener said, let's go for a walk. And he took them out and pointed to the ice and pointed to the sky and said, we're trying to find out how all this works. It doesn't matter whether we live or die. The important thing is that the work go on.
And I guess that's why I love Alfred Wegener, because it's not really about himself. It's that he believes in science, a kind of great metaphorical expedition.
At the end of all this, they were able to supply the station at the middle of the ice, and then they got there, and there wasn't enough food to last the winter for all of them. Wegener said, I'm going to go back to the coast. He didn't like to ride on the dog sled. He liked to ski next to the dogs. He had a heart attack and died. He's still there. The German government wanted to bring him back for a big funeral, and his wife said, no, leave him there. He's where he wants to be.
All right. Where was Wegener known to study? The Arctic. And specifically, he did a lot in Greenland. What did the depth of ocean water around the continents resemble? What did it look like? All right, so it resembles. So that was the part of the video where they had the map of the continents and they were drawing the lines around it. That was like the same, they're called iso lines. That's called where the same depth of the ocean was, and it was matching right up with the continents. That's that continental shelf we were talking about earlier. All right. Why did botanical people respond to his idea so positively? Why did the plant people like him? Why did the plant people? Because all the geophysicists were calling him stupid because he didn't know what he was talking about. But why did the botanists like his theory of continental drift? Say it again, Marcus. Oh. No. So remember when we were talking about that fossil correlation? So plants and animals were across the continents. So the botanical people, which are people who deal with plants, did not understand why there was the same fossils on different continents. They couldn't just fly from one continent to the other. No dandelion is that strong in flight. So his theory explained something that they couldn't answer, and that was the distribution of the plants worldwide. Including current plants as well as fossilized plants. All right, and number 4, Wegener proposed his idea in 1912 originally. What decade did people begin to believe some of his ideas? Ooh, nope. It was at the very end. They put it in text. What decade? I'll give you a hint. He died in 1930, and it was after he died. Nope. Good. Nice, Akil. 1970s. So it wasn't until 40 years after he died that they were like, this guy might have actually been onto something. So, yeah, well, that happens. Look at what's happening in the world right now. All right. Back to the notes. I know.
I got an AirPod in? What the heck? It's not on my ear.
All right, so back to how do we know about plate movement and location? It all comes back to convection currents. We'll literally be talking about convection currents for the rest of the semester, all the way to natural, disasters. So land and ocean features have also keyed scientists into the relation of plate movement. So we look at things like oceanic drilling to tell us the ages, the seafloor spreading patterns, earthquakes that happen along all 3 boundary types, the volcanoes at convergent and divergent, and hot spots, which you guys live extremely close to a hot spot, that show intraplate movement. I love Arizona. Mm-hmm. Yep. That was like when we had my Hawaiian family over for Thanksgiving. They ate dinner in parkas. All right. Oceanic drilling. So this is what I was talking about earlier, one of the big studies that went on for almost 20 years. The Glomar Challenger was the name of the drilling ship, and it was like a joint operation. There was government, there was like Navy, there was scientists, a whole bunch of people. They drilled hundreds of holes through layers of sediment and rock at the bottom of the ocean, and brought up like core samples. And then radioactive dating, which we'll talk about a little bit later on, doesn't work on ocean sediments. So they used fossil of microorganisms. So they had to identify what the microorganisms were and kind of place a date on their death and when they were around. That proved that seafloor spreading hypothesis was true. The youngest crust is found at the mid-ocean ridges, and as you get further and further away from the crust, from the mid-ocean ridge, it gets older. Yeah. All right. You're a strange soul. All right. Paleomagnetism. Oh, this is one that cuts off again. Hold on. Paleomagnetism. Sometimes the Earth's magnetic field reverses. Positions of the magnetic and north and south poles interchange with each other, while geographic north and geographic south always remain the same. So our Arctic is always going to be in the North Pole, and our Antarctic is the South Pole. But the magnetic, the things your phones, the computers, GPS all work off, will actually switch. So the evidence of that is when the lava comes up through those mid-ocean ridges and it cools, the minerals within that lava will align with the magnetic field. So there's things like iron, ferrous metals, that will align to that magnetic field. Those stripes form on both sides of the mid-Atlantic ridge, and they show that pattern of mineral alignment. So as those lines shift and change, then that's how we know that poles have moved as well. The picture I'm going to show next is in your notes, and you can probably see it better in your notes, but it'll show what I mean by the pattern at the mid-Atlantic ridge. Hopefully everyone's got that one. Could you do that quieter? All right. This is really large. I gotta fix that. There we go. All right. So here's the picture that is in your note packet, where you have your mid-ocean ridge here in the kind of grayish white area. It's hard to see on this one, but it shows arrows pointing down. The pinkish area have arrows kind of pointing up, and that's what we mean by the mineral alignment. So we know, just like you can see with magnets or a compass, anything like that, that where north is. So that's where those arrows are pointing. And on either side of the mid-ocean ridge, then you can like almost collapse it together and it'll be a perfect match. So it's mirrored essentially across that center line. It is. All right, what causes this? What is Earth's outer core made of? Remember, our outer core is liquid. It should say nickel and iron, but it got cut off for some reason. It should say liquid, nickel, and iron. Our inner core is solid, our outer core is liquid. All right, that spinning and churning of this layer creates our magnetic field, the stuff that protects us from like the gamma rays and stuff from the sun, so we don't get killed by UV every time we walk outside. Sometimes resistance builds up with the subducting plates and everything going on, that the magnetic poles will reverse. This reversal can occur between every 1,000 and 1 million years. So, oh my gosh. Isaiah, you're going to be the death of me. Here's, stop it, there we go. That's why it should say liquid, nickel, and iron. So it's a very wide gap from the 1,000 to 1 million years. And it's not just like an overnight switch. It takes that long to actually do a full reversal. All right. Quick quiz, 4 questions. I know you've got a record to uphold now.
Never mind, I'm gonna get that wrong.
Stop it. Cheater.
Oh, it's been right there. How did I not read that? Oh my god.
All right. I'll let you guys finish up. The bell is going to ring here really soon. We'll finish the notes up next time I see you, which is what, Friday? Yeah, Friday. So once you get your 4 questions done, you can close out, save your notes, and we've got like 1, 2, 3, 4 more slides, and that's it in a video. But it's about Hawaii, so I like it because I love Hawaii. Do you know where you're going next?